This video, we're going to look at the runoff and sources for a road and the issues they cause on the road. So usually the rain, the water on a road comes from the rain. Rain falls down, um, lands on the surface. Um, it also can soak into the ground and become part of the water table, or there's other ways it can sort of get into the subsurface as well. So the two types of water that we're concerned about are surface water, which is on the road, and subsurface water, which is under the road. That subsurface water can be in the formation, in the subgrade, or it can be a bit further down, or it can be flowing in from the sides. So we'll look at that more in later slides. So let's look at the surface water sources first. As I said, the main source of water is obviously rain, but it can be flooding as well. So you've got runoff from uh, uh, land surfaces above the road, so they'll flow down and hit the road. You've got the rain falling directly onto the road and at ponds, but obviously we shape the road with a camber, so the water does shed, but obviously it's still flowing across the road. In the heavy rain, you can get a bit of a sheety layer. And also the groundwater can be coming out of the ground, causing springs, and once again flow onto the road. So that's the surface water. And the problems that surface water causes is normally, with just a normal downpour, it's not so much of a problem. But when you get a big downpour or the drainage system isn't working, you get surface water like this. So even a thin layer of water on a road can hinder the grip between the tires of the car and the road. And so the car doesn't have as much control, as much grip. And we've all seen it when a car sort of spins out in the wet. It's basically lost that grip between the road and the car, and then the car loses control. You can see here when there's significant amount of heavy of rain on the surface, and there's usually heavy vehicles, they'll kick up a lot of spray, and so that's impaired visibility. Once again, you can see there's a lot of flooding here as well. So if it gets too bad, then cars or can't get through it. And then there's environmental contamination. So the cars are actually, there's contamination on the roads. The cars drop oil, the tires leave stuff on the road. So all that water, that surface water, is washing those contaminants off the road and into the stormwater system, and then from the stormwater system into the natural water system. So those are the issues we need to have with surface water. Subsurface water, so you have the water flowing under the ground, so you have groundwater flow. You have the water table, which is going up and down all the time, and sometimes the surface is slightly cracked or not as impermeable as it should be, and water might be seeping in from the surface. Also, if you've got, say, flooding in a curb and channel, or you've got a table drain, then the water can flow in from the side underneath the road as well. So what that can do, that subsurface water can do a number of things. So if the water is flowing down and ponds or gathers in the subgrade, then it can soften the subgrade, and that can cause the subgrade to settle. And once you get settlement of the subgrade, you're going to get settlement of the road surface as well. You can also, so that's what this video shows here. So that a particular area gets wet, and then it compacts. Normally you shape the subgrade to actually shed the water, but sometimes when a depression starts happening, the water starts ponding, and it just accelerates the problem, because more water ponds and it gets softer and it settles more and so on. Another problem is water in the pavement. So if the water's in the pavement, the sub-base or the base course, then if it's totally saturated, then every time a vehicle goes over the top of it, it pressurizes the whole the pavement structure. If there was air there, then it wouldn't be a problem, but there's water, and water is incompressible, so the water acts to push the particles apart. So it's like when you get a balloon, if you sort of crush it, it'll squeeze out either side. A water balloon, I mean. If you get a water balloon and crush it, it'll squeeze out either side. So it's much like that. It actually, as the cars go over top of it, it creates hydrostatic pressure, which tends to push the particles apart, and they can move, dislodge, and then this pavement interlock starts to come apart. And another issue is if you've got the subsurface water can actually bring, if you've got a clayey subgrade, it can actually bring the clay up, and it can cause clogging of the subbase. Um, the subbase and the base course are actually designed to drain water. So some water will get in there, but it drains down. So it'll drain out and then hopefully drain out of the subgrade, and it's not going to get to the point where it's going to cause a problem. So a little bit of water is not a problem. But if the clay particles get carried into the subbase, then it becomes impermeable. So water ponds above it. So once again, you've got a saturated pavement layer, and that's going to cause that hydrostatic pressure trying to push the whole pavement apart when cars go over top of it. So you can see that both surface water and subsurface water cause problems, and we need to manage those when we're designing a road.